Assalamualaikum warahmatullahi wabarakatuh. Today we will learn the completing square and long division. Okay, these techniques will be used for integration the partial fraction. Okay, which is the last techniques of integration we will be learned in this course. Okay, this is the review topics for partial fraction. Okay, let's look at the completing square. The techniques of completing square. Okay, the solving general quadratic equation by completing the square. Okay, we can complete the square to solve a quadratic equation. Okay, this is example of completing square in order to solve the quadratic equation. Okay, but in this topic, okay, we will use the completing square to solve the integration. We just look what is the completing square. Okay, but a general quadratic equation can have a coefficient of a in front of x square. Okay, for example, we have this quadratic equation ax square plus bx plus c equal to 0. It is in the quadratic form where the degree of x is equal to 2 or the power of x equal to 2, but that is easy to deal with. Okay, just divide the whole equation by a, where a is the coefficient of x square. Okay, then carry on. So x square plus b over a x plus c over a equal to 0. Okay, this is example for completing square in solving the quadratic equation. Okay, let's look at techniques to completing the square in order to solve the integration. Okay, first we look at the techniques. Okay, if the coefficient for x square is equal to 1. Okay, so x square plus bx plus c. Okay, so equal to x plus b over 2 square minus b over 2 square plus c. We use this form of equation for this quadratic function if the coefficient for x square equal to 1. Okay, the second one, if the coefficient for x square is a perfect square. A is a perfect square. A is perfect square. Okay, so what is perfect square? Okay, perfect square is an integer that is the square of an integer. It is the product of some integer with itself. Okay, for example, we have the square root of 9. So it is the perfect square. 3 times 3. Or the square root of 16. It is also the perfect square. So 16 is a perfect square. 4 times 4. So we use this techniques of completing square. The square root of a x plus b over 2 square root of a square minus b over 2 square of a square plus c. And the last one, the third one is if when a is not a perfect square. A is not a perfect square. So when a is not a perfect square, we have to factorize the value of a. This one, we have to factorize a. Then we will have a times x square plus b over a x plus c over a. Okay, then we follow the techniques of number 1. So a, then we follow number 1, x plus b over 2a square minus b over 2a square plus c over a. Okay, look at this example 1. Okay, example 1, okay, x square plus 4x plus 3. Okay, this is the coefficient for x square equal to 1. So we use the first techniques. We just use the x plus 2 square. Okay, this one b is will divide by 2 x plus 2 square minus this one. Okay, x plus 2 square. Okay, minus 2 square plus 3. So we will have x plus 2 square minus 4 plus 3. So we solve this. Negative 4 plus 3, we will get negative 1. And number B, okay, 7 minus 6x minus x square. Okay, we have to rearrange this form, this quadratic. So we will have negative x square minus 6x plus 7. Okay, then we have to make this x square, the sign for x square is positive sign. So we factorize the negative sign, x square plus 6x minus 7. Okay, this one. Okay, then we factorize this. We use the completing square based on the first techniques. So x plus, okay, we divide b by 2. This coefficient for x divide by 2, so x plus 3 square. Okay, minus this one is 3 square. Okay, that's why negative 9 minus 7. Then we solve this part, negative 9 minus 7, so negative 16. So it will have 16 minus x plus 3 square. Okay, now the third one. Okay, this one. X, the coefficient for x square is not a perfect square, right? 2. So we factorize this 2. So we factorize this 2. So we will have 2 times x squared plus 2x plus 5. Okay, then we solve this part. Okay, using the first technique. So we divide the coefficient for x divided by 2. So you will have x plus 1 square, okay, minus 1 square plus 5. So you have plus 4, this one. Then the final answer will be 2 times x plus 1 square plus 8. And the last one is if the coefficient for x square is perfect square. This one is perfect square. Perfect square. So if perfect square, so we have to square root this 4, square root 4. So we will have 2x minus 12 divided by 2 times the square root of 4, 2. So we have 3, negative 3. Okay, minus this one, negative 9 is negative 3 square. So we have negative 9 plus 13. So we solve this part and it will get 2x minus 3 square plus 4. So we will use these techniques to solve the integrals in the form of rational function, in the form of fraction 1 over ax squared plus bx plus c plus x dx. So we have to complete the square for denominator, this denominator. We use the completing square method, and the second one, make the appropriate substitution. Okay, normally the solution is in the form of inverse function. Okay, this is the example of solution for inverse function. Involve the completing square method. This one. You can look at one by one. This is in the form of tangent inverse. The second one, in the form of hyperbolic tangent inverse, or we use another, this one, techniques of integration in Lon form. And the third one, which is the inverse of cosine function, hyperbolic. And the number 4, okay, these techniques of these types of integration will be listed in the appendix. So number 4 is the sine inverse, and the last one, the last example is for the inverse of hyperbolic sine. Okay, let's look at the example. A few examples. Evaluate these integrals by using the completing square method. Okay, look at the first one. Okay, we use completing square method to solve this part, this denominator part. We can't simply integrate this function 1 over this function. It is complicated, so we have to use the completing square method to simply this form of function. Okay, so this is the coefficient for x squared is equal to 1. Just factorize, simply factorize. So x minus 1 square minus 1 plus 5. So we have this function, this type of function. Okay, then we use the techniques of substitution to solve this integration part. It is in the form of rational function. So we use substitution. We let u equal to x minus 1. We let u equal to x minus 1. Then du, we differentiate u with respect to x. So du equal to dx. Okay, then we substitute into this function of u into this function. So we have 1 over u square plus 4. Du is dx. Dx is du. Okay, then this form of integral, okay, is in the form of tangent inverse. So 1 over tangent inverse is 1 over a. The formula for tangent inverse integration of this form is using tangent inverse 1 over a, tangent inverse u over a plus c. Then we substitute the value of u with x minus 1. So the final answer must be in x, in term of x. Okay, B also we have to use the completing square to simply change this form into the simple form. So it is we have to make this sign of x square into positive sign. Then we use the completing square. It is the equation for x square equal to 1. Then we can integrate this form of function. Okay, it is the inverse sign u over 6. Okay, plus c. Then we substitute u with x. Okay, question number 6 and 6D. Question C and D, you can go through by yourself. It's the same method. And also E and F. Okay, now we look at techniques of long division. Okay, we use this technique of long division if the function given is in the form of fx over gx. Okay, fx over gx is an improper rational function. Okay, if the degree of the numerator is larger than or equal to the degree of denominator. Okay, for example, we have this improper fraction or the improper rational function. Okay, number 1, we look at this example, x squared plus 1, okay, divided by x squared minus 2x plus 3. Okay, it is the improper, okay, because the degree of numerator is equal to the degree of denominator. The degree is equal to 2. 2 for numerator and the degree of denominator also 2. So we have to use long division to solve this integration in the form of this improper function. Okay, now we look at number 2. X squared plus 1 over x plus 1. Okay, it is also the improper function. Okay, because the degree for numerator, this one, the degree for numerator is equal to 2, is larger than the degree for denominator. The degree for the denominator is equal to 1. So we have to use the long division method to solve the integration of this function. Okay, if an integrand is an improper rational function, then the long division, or we can call it algebraic manipulation, need to be performed to change the integrand to a proper rational function. Okay, let's look at example of improper rational function to a proper rational function using long division method. Okay, we look at, there are 4 examples, A, B, C, D. Okay, we look at the solution. Okay, this solution. We have to transform the improper rational function into this form. So the numerator, this is for numerator part, x minus 1, then divide by x plus 1. It is the denominator part. Then we have to multiply 1 times x plus 1. So 1 times x plus 1. So we put it below the numerator, x plus 1. And then we solve this. We solve this. Okay, the original numerator minus the new one. So x minus 1 minus x plus 1. So we get the balance is negative 2. So we write this into, you write the all improper function into, okay, 1 plus, okay, this one is negative sign, so 1 minus 2 over x plus 1. So it is in this form, the new form. The new form is in rational function. The new form is in proper rational function. Proper rational function. The old one is improper rational function. Okay, let's look at example 2. Okay, the numerator we have to divide by denominator. Okay, then first we look at this part 2x cubed. Then we want to get this 2x cubed. Okay, we have to multiply what value? X, to multiply of with x square. So we have to multiply with 2x. 2x, right? 2x. Then 2x times x square minus x is 2x. We get 2x cubed minus, multiply with this, 2x minus negative x. We get negative 2x. Okay, then we put the negative sign. We have to subtract this value, 2x cubed. Okay, minus 2x cubed minus 2x. We have the balance of 2x squared, okay, plus 3. below. Put it below 2x squared plus 3. Then we want to solve 2x squared. Okay, we have to multiply this denominator part with 2. 2 multiple with denominator. So 2 times x squared is 2x squared plus 2 times negative x is negative 2x. Then we solve this part, these two. Okay, we will get 2x squared minus 2x. Then this value is 0. Okay, 3x plus 2x is 5x. Then we bring negative 1 in beside 5x. So 5x minus 1. So this is the balance. So we write this into proper rational function. Okay, so the proper rational function is 2x plus 2 plus, the sign is plus, so plus 5x minus 1 divided by denominator, x squared plus 2. Then we can simply integrate this form of proper rational function. Okay, you can go through this solution for C and D, which is in the same way. So multiple, we have to write in this form the improper rational function into this form. Okay, numerator divided by denominator. Okay, multiple denominator with 2x. So we get this answer. Then the second one, we multiply with this denominator with 6 plus 6, we get the 6x squared. Okay, minus 18. Then we cancel this 6x squared, 0. Then plus 18x. Okay, we bring negative 1 beside 18x minus 1. So this is the last solution. So you will get the solution is in the form of proper rational function, is 2x plus 6 plus 18x minus 1 over the denominator, x squared minus 3x. And the last example, okay, we multiply the denominator with 3x squared. Okay, 3x4 is the guideline. So we get the 3x4 plus 6x cubed. 6x cubed is from this 3x squared times 2x, we get 3x cubed, and then 3x squared plus 1, 3x squared times 1, so plus 3x squared. Then we multiple. We have to subtract this. So we get negative 6x cubed minus 3x. Okay, we bring 3x below. Then we want to find the negative 6x cubed. So we have to multiple with negative 6x with x squared. So we get negative 6x cubed. And then 2x times negative 6, we get negative 12x squared. And then 1 times negative 6, we get negative 6x. Then we use negative sign to solve this. So 0. Then this one is positive 9x squared plus 9x. Okay, we bring negative 1 below. Then we repeat the techniques to get 9x squared. So we will multiply with plus 9 times x squared. So we get 9x squared plus 18x plus 9. So we use minus sign to solve this. So 0. Then this one negative 9. Okay, negative 1 minus 9 is negative 10. Then we write this into proper rational function. So 3x squared minus 6x plus 9. Okay, minus this one is minus 9x plus 10. Or we can also write plus sign. Plus, we can also write 3. This one is 3x squared minus 6x plus 9 plus negative 9x minus 10 over x squared plus 2x plus 1. So this is the last example. Okay, the reference is from Zakia Umar. Okay, thank you.